this is a hands-on session. That was my primary goal, was to make sure that everybody here, or as many people as possible, it won't be everybody, but as many people as possible, have the opportunity to actually run Docker on your local laptop. I'm one of those kind of learners that have to touch the software. I have to work with the software, otherwise sitting and watching slides all day, it doesn't really do much for me. I got to really kind of get my hands on it, break it, tear it apart, 3 hours later figure out what I broke that was my fault, put it back together again. That's how I learn things. And so that's why I wrote the tutorial, so you guys could have kind of a real hands-on step-by-step of what it takes to get from nothing to Docker actually building Java applications that connect to MySQL. So the ultimate goal was to have an application server running a WAR file. There's even a Maven, how to build it for example app. Take the WAR file, deploy it inside your Docker image, and connect it to a MySQL database. And that might not seem like much, but it actually is a fair bit. And that is the ultimate, in my mind, developer sandbox, if you will. That's primarily what we do, right? We take things from a web user interface, we shove it in a relational database, we get stuff out of a relational database and put it back on a web user interface. That's 85 to 95% of what we do in average enterprise IT. So that's why I wanted to show you that particular use case. And I got to try not tripping over the wire. Okay, so that's my Twitter handle. You'll see tweets from me related to this kind of content. There's some out there now related to Docker. And then also, if you go to my blog, burrsutter.com, you'll see other Docker-related information, Docker blogs. And then the actual tutorial itself is on GitHub. So github.com/burrsutter. You'll also see a lot of tweets from me switching into IoT mode, Internet of Things mode. So for April, May, June, I'll be talking a lot about Internet of Things. So don't be confused if you see too much of that content coming up. So we're going to give you an ultra brief overview. Our goal is to get hands-on as much as possible to show you the technology, not basically talk at you about what the technology is about. And my preference is so you guys can see it. There are the hands-on tutorials right there. Those are the URLs for them. So if you're able to get on the network at this point, bring up the browser and go ahead and open up github.com/burrsutter/Docker tutorial. I imagine some people are now moving over to their phone hotspot at this point. Okay. If you did not bring a laptop, that's perfectly fine. We'll walk through it all, right with everybody here in the audience. We'll kind of walk you through every step and kind of explain it as we go. If you have questions, we'll talk about those things. But for those of you who don't have a laptop, practice pair programming, right? How many people do Agile now, and there's some form of Agile in their shop? Come on, most hands should go up. We do some. At least we have a Scrum meeting or something like that, right? And so, how many people do pair programming? See, hardly any hands go up. This is your opportunity. There's some pairs right there. All right? This is your opportunity to go pair programming. I actually call it cheek-to-cheek programming. Right? Ass cheek to ass cheek, right? That's how it works. But if you've not heard of pair programming, there's an awesome YouTube tutorial on how to do pair programming. If you have not, don't watch this now. We don't have the network bandwidth to pull this off, but when you get home, I sent this out on Twitter a moment ago. You definitely want to see this this is the Latticen folks, the Bitbucket, little Bitbucket tutorial on Git programming and pair programming. It's very nice, very well done. So really awesome video. Okay, so what is Docker? So the first thing to understand about Docker is Linux technology. So even though the tutorial is written for a Windows person and there's lots of Mac tips and tricks in there, the ultimate goal is to get you into the Linux world. All right, so Docker is Linux container technology, and so containers are a bit different than virtual machines. So most people will probably, if you're coming from a Windows background or a Mac background, you know what a virtual machine is. You've heard of you've seen those things, heard of those things before. And here's the million-dollar pitch for a Docker container. An average piece of hardware, whether it be this piece of hardware I have here or a data center 1U rack-mounted server, average piece of hardware, physical hardware, you can run 10, 12 virtual machines on that. That's kind of the rule of thumb. You can do more, you can do less. It all depends on how much you overallocate memory and I/O and CPU and things like that. But you typically run a handful of virtual machines on a piece of hardware. In the case of containers, you might run 1,000 containers across those 10 VMs. So containers are much smaller, much tighter, and you have way greater flexibility with how you kind of turn them up and turn them down. And so that's why people are so geeked up and excited about containers. It's like the level of density has gone through the roof. You have a great deal more manageability around these little guys. They start really fast. They're really easy to work with. And people just love that idea. A Linux container is nothing more than a Linux process. All right, it's a highly protected Linux process. It only has access to what it sees in its domain and its boundaries, right? So we use something called C groups and some other tricks for that. But by default, it's just a Linux process, and you can treat it as such, okay? Now, Docker also, in addition to finding this Linux container thing that everyone's so excited about, it's also a company and an open source project. The project's only about 2 years old at this point, and it has already changed the world. So that's kind of cool. You see that happen in open source land every now and then, right? You know, open source kind of, you know, if you guys have been around the Java community a long time, you saw struts happen, you saw Spring happen, you saw Hibernate happen, and now everybody had to do Hibernate and everyone had to do Spring, and now you've given up on struts and moved to Spring MVC or something. But, you know, open source does change the world, the techniques and tools that we use on a regular basis. Docker kind of falls in that category now. All right, so Docker has now changed the world, and it's only been out there a short period of time. So it is a company, though, also called Docker, formerly called .cloud. Just remember that one, because they were a platform as a service startup, and they kind of transitioned themselves, pivoted themselves into being the Docker company, the container company specifically. So this is the challenge most of us have as Java developers. All right, and I'm hoping I'm speaking to a lot of Java developers. If not, if you're Ruby or not a Node.js, just play along. It's like, wow, those guys really have to work real hard. You know, those Java guys are working really hard. So if you're dealing with Java land, right, you always had, in production, you had your server hardware. That was pretty well known. You had a server operating system. These days, it's often some form of Linux, right, out there, whether it be Red Hat Enterprise Linux or something else for, you know, Ubuntu or something else. Might be Windows even, but you had a server operating system. You had a Java virtual machine on top of that also. And then you put your application server and your custom configuration, right? So that your custom configuration is your data sources, your JMS, your message queue definitions, your user IDs and passwords, whatever it is you needed to make your app run. And you put your WAR file on top of that stack. Are you guys with me on that one, right? So you had the stack, we talk about the stack, and you put your WAR file, boop, drop it right on there, and you hope it runs. And sometimes it did not. And here's why. Because every systems administrator and ops person might have organized that bottom set of layers kind of differently. Oh, I didn't hear the user ID correctly, or I didn't know what the JMS message queue was. Or better yet, I have a capital letter someplace I shouldn't have had, you know, or a lowercase letter someplace I shouldn't have had. Or a simple backslash versus forward slash if you're going from a Windows development environment to a Linux production environment. You know, I'm looking for a file on the file system, I use the wrong slash. So that happens all the time. Who's felt that pain before? Some little gotcha like that. Okay, good. It's a large number of you. I wasn't lying when I was saying these things, right? I wasn't guessing. So here's the coolest thing about containers now, and you'll see this when we get into the tutorial. You no longer stand up all that infrastructure technology in production and throw WAR files over the wall at it. That's no longer the way we go anymore. We now have this concept of immutable infrastructure, right? Programmable even infrastructure. And the idea is you actually build the stack as a Docker container, Docker image, with your WAR file in it, and that whole thing moves to the deployment pipeline. So you might even build it locally here, though I don't necessarily recommend that. Then you check in your code and you build it on Jenkins. That's more recommended. And then Jenkins publishes it over to a QA or dev test environment, and then from there maybe to a staging environment, and then from there to production. And it's the exact same thing moving down that chain through that deployment pipeline. So this is the magic of what Docker containers, or containers in general, Linux containers in general, bring to the table. Is you can basically package it all up in one nice immutable package, and you know what's in there. You know exactly the Java virtual machine with the right patch that you need, because I don't know about you guys, but I've had patches for the JVM break my stuff. And that pisses you off like nothing else, right? It's like, what? You know, because you can't figure out where the bug is. It's nowhere in your code. It's in the JVM itself. So, you know, you want to know exactly what the operating system version is. You want to know exactly what libraries have been installed in the operating system, supporting libraries, the JVM, configuration when it comes to data sources, etc. All that's prepackaged, and you know it works. You tested it all, and you move that whole component now into production, is the idea. So the real difference between virtualization and containers is in the virt space. You could do this with virtual images, like a really large company here in town, a .com, I won't name the name, but some of you might work there. You know, they specifically roll out 200 images to production to support their 200 servers, right? So they've been doing this for years and years and years on their public-facing website. It runs JBoss, and they basically will package it all up in a nice virtual machine image and move that out. So you do the same with containers, right? You package it up in a container format, container image, and move that out to production. The biggest difference is a virtual machine image includes the entire operating system. It is the whole guest OS, right? It is the whole operating system. In the case of the container, it does not give you the whole OS. So for those of you who are pretty Linux savvy, you might see one of the disadvantages of going with containers now. Who can see the potential problem and not having the whole OS over on the container side of the house? So basically, I'll tell you what the secret is. Somebody could actually have had, let's say, Ubuntu running on RHEL, or they might have CentOS running on Ubuntu, or Mint running on Yocto, or something else, right? You can mix and match, but that's not going to really be all that recommended because these things are shared, all right? The underlying binaries from the host OS are shared with the guests in the case of containers. So I just encourage you to think about that a little bit. Don't think while you can go higgly-piggly, and you're going to see it, it's not necessarily the most safe way to go. You want to kind of think through your stack again and make sure your operating systems more or less line up, because those are, there's going to be things that are shared between the host OS and the guest container in this case. Okay? But the reason that stack is much smaller on the right-hand side is why this thing runs so much faster and why it's so much lighter weight and so much easier to use. Because you're not packing up a whole entire operating system with all its supporting binaries and dependencies to move into the container. The container is just a small thing. Okay? So the pros are containers start very fast and take less memory. When you get started here, for those of you who are following the tutorial now, when you do your Docker run CentOS, it's going to start like that. And you're going to think, wow, wait a second. When I start a virtual machine, I go get coffee. And I come back and see if it's done, right? Especially on some of the older machines. But in the case of the CentOS image or the Ubuntu image or whatever, it's going to start instantly. And it's kind of going to blow your mind. It's like, did something really happen? Maybe nothing really happened. Let me run it again, which won't actually work because you've already run it and shelled into it, hopefully. So it's also super easy technology to work with. So all the things happen on the command line. You're going to see that. So you're going to do Docker pull, Docker run, Docker this, Docker that, Docker, Docker, Docker. And it's super simple to work with. Once you know the basic commands and once you follow the tutorial, you'll be able to rock and roll from that point forward. You'll really be off and running. So that's one thing I really like about it is once you get through the initial learning curve, which hopefully we're going through in this session now, you're off and running. It does support the immutable image deployment model we were talking about, right? You build that whole container image, and then you push that whole unit out, right? And actually one of the things I can show you, if you guys have the flash drives that have gone around, one of them is called Docker images in the folder, and that's because I actually serialized out the Docker images on my Mac and moved them to the Windows machine. So you can actually push out an image to a tar file and basically suck it back in on another Docker. It's pretty nice, right? So the whole concept of being able to package things up is very nicely done. Okay? It also caches layers during the build. So if you just make changes, it's a layered build system. So when you just make changes at one layer, it doesn't rebuild all the other layers. So you we'll see that as we go through it. All right? But it's not a VM. All right? You're not a wholly protected guest OS inside a virtual machine. Just bear that in mind. It's not perfectly portable. Right? We talked about portability in the abstract, and that's kind of how people think of it as portable containers, things like that. It's not perfectly portable. You do need to worry about what the host OS is and what OS you expect to be running inside your container itself. You need to be thinking those things through. There's another thing that you'll see when we start talk about Docker Hub here in a moment is a lot of these things come from people. Now, you guys all use Maven Central for your Java-based builds, right? Where do those jar files come from? Yeah, the Maven dependencies, they could come from anybody, though. Any crazy person can be building those jar files. Docker Hub is the same way. You have all these cool images people have created and contributed out there. I've put 2 of my hacked up images up there, and Arun Gupta, where I got a lot of this information from, he put a bunch of images up there. But you have to have some faith and trust in these people who are putting those images up there. And so that's a question I've had multiple times of, hey, why don't I just use Docker Hub kind of in production? Yeah, you wouldn't do that. Right? Because you don't necessarily know where these images came from. You don't necessarily know their lineage. You want to make sure that your enterprise has their own Docker Hub, your own registry running inside your 4 walls, inside your firewall, and then you have your own images that you've created for your team, right? So that way you know exactly where your parts came from. That's my recommendation at least. Okay, so Docker commands look like this. Docker PS was tell me the processes that are running. These are the Docker containers that are running. Docker images shows me all my Docker images that are local. We'll try some of these. There's the pull, there's the run. You guys will be doing something like run -it. You might see -i-t or -it. That's interactive, and it gives you a TTY session. Basically allows you to have your keyboard commands reach into the shell of that running container. So you guys will get a chance to see that in the tutorial also. And this is the registry. Let's just see if we can go out to the registry. So, okay, so this is the registry. So you can just Google Docker Hub. Otherwise, it's registry.hub.docker.com. And this is where a lot of your images come from. So in the tutorial itself, we're having you pull CentOS Wildfly, MySQL, Jenkins, whatever it is you want to pull down. Basically, it's coming from this repository up here in the cloud. So just remember, this is your friend. You can come up here and search it. So you can see we did you can say, where's the search screen? I lost the search screen. But this is one cool thing is this is the image for the registry itself. So you know how you can run a local Nexus repo, right, or Artifactory or something like that for your Maven dependencies? You can run this Docker image locally, and now you have a Docker registry locally, which is kind of cool, right? And then therefore only your images can be stored there, and your blessed images can be a part of that. Let's see if I go back here. Yeah, so search the registry. So let's say I want the Jenkins image because I want to pull Jenkins down. Hit search there. And wow, we are really slow now, aren't we? There we go. So you can see there's the Jenkins, the official Jenkins Docker image, but there's a whole bunch of other things too. So here's one trick to the Docker registry. If you notice if it's a single word, that's pretty much one of the blessed images that Docker themselves have said, yes, we have the Docker image for Jenkins. If it's two words with a slash in between, typically that's the username, right? The user who's crafted the image, and that's their repository, and then the actual image name. So you can see that this individual here, Espinoza, yep, built a Jenkins image, and Simply Intricate built a Jenkins image. So that's kind of how you know when you cross the boundary into, let's say, a blessed image into more of a user image. Yes, sir?
Would you trust official Jenkins Docker images, or would you trust official Docker images?
Yeah, so one of the things you'll see in the tutorial, I have no problem with the official repos personally, but one of the things you'll see is there's another command out there called Docker History, and you can actually see the history of that image, and then that'll give you a little more insight as to how it was built, who built it, and most of them also have a GitHub repo where you truly can go see how they built it, and then that would give you enough confidence in it. But building your own Jenkins image is super easy too. So, once you get through the tutorial, you'll be able to build your own Jenkins image if you want. Pretty straightforward.
And also they have a ranking, right? If you go back, they have a ranking and how many times if you download it, that's also given.
Yep. That's a very good point. They kind of a star rating and then a download number there. And that does give you a little more confidence that a lot of people seem to be using it and liking it. So I don't want to, discourage you from using these things because you use Maven Central today blindly in many cases, right? You don't know where those things came from. Use gem, right? Ruby gems, use Node.js NPMs. All these hosted repos have the similar problem. People can upload whatever they want to, and you're having some faith and trust in the system, the community, if you will, to make sure that you're getting a clean thing downloaded with no backdoors built into it and stuff like that. In the case of these Docker images, though, I would be a little bit more cautious because it is an operating system with a bunch of code running inside it. It's not like a jar file. You know what I mean? A jar file is you can control that jar file a little bit better. This is actually a thing that is now running. And if it wants to open up ports, and move back across the internet, it could. So I just warn you about that, just so you guys are thinking about that. But you will spend time on this user interface. And you can also do a search. Let's see how fast we're running. You can also do a search from the command line. So Docker search Jenkins. So we'll talk more about this command line in a second. And you can see it's not going very fast right now. But you can do searches from the command line in addition to the user interface. And it timed out on me because the network's so slow, and I'll try it again. Yeah?
If let's say that instead of going to the main Docker Hub, if I want to go to my company's Docker Hub, is it a configuration that when you do it, you set up that what should be the Docker Hub used?
Yeah, it's just by default, it goes to the main Docker Hub, just like Maven does, right? Maven Central. But you can just switch the setting to say, I want it to go to that IP address over there, or DNS entry.
That's the registry you will be running maybe in your network.
Yeah, that's the registry running on your network. Yeah. All right, so let's keep rocking and rolling here. Wow, even Google Docs is slow. Okay, one other quick tidbit. I use this book. So when I was teaching myself Docker, I read through this book and tried a lot of the examples in it, and to some degree you'll see some of those examples here in this tutorial. But once you get through this tutorial and you got Docker running, you'll kind of be ready to go. I'd recommend getting a copy of this book, and if the network wasn't so slow, I'd say get on your Amazon account right now, buy the Kindle version, download the Kindle app, and load it up. It is a fantastic book, I think very well written, and it walks you through how to do all sorts of things. My favorite one, it shows you how to do like Nginx and Ruby Sinatra and just different examples of how to do different things. But my favorite one is how to do a Docker image, which includes Jenkins and Docker. So Jenkins can build Docker images. Yeah, so you're thinking that's kind of recursive, isn't it? Yeah, exactly. So you can have a Docker image running or Docker container running with the Jenkins instance inside it, so that when you check in your code to GitHub, let's say, it pulls that into Jenkins, it does the build of your WAR file, and then produces the whole Docker image that you move down the food chain. And the cool thing about that is if you can now basically say, from a QA standpoint, I want to test my code on Red Hat Enterprise Linux, CentOS, Ubuntu, blah, 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 blah. You can have like 4 or 5 different Docker images produced with your WAR file and all your app server config set up there, the JVM that you want with all the different operating systems you want to support, and all that gets pushed to running automatically in QA through Jenkins. So that's cool. So the book covers that use case, which I think is a particularly cool use case. It's kind of more of an advanced use case for this intro session. All right, so these are the tutorial links. So github.com/Burr-Sutter, Docker_tutorial, and Docker_MySQL tutorial, which you get to as the second phase. But let's kind of walk you through it. So we're going to just walk through this and see how far we get with the time we have remaining. So we had you guys install boot to Docker. I sent out tweets, I mentioned in the abstract, go to my blog. We've been talking, you could have had boot to Docker installed well before now. If it's not installed now, it's probably too late because it's just going to be too slow. Did you ever get around that error you had? Yeah, it doesn't like being offline to get the initial installation going, so I'll just warn you with that now. But I installed boot to Docker on a different machine other than this one, and you can see in that case I did not select, great, it's so slow I can't even open up the image. I did not select VirtualBox on that installation, so you can pick and choose, but keep in mind you will need all 3 of these things. So if you already have VirtualBox, that's okay, but you will need it configured, installed correctly to make it work. Okay, so a couple other tips here. You notice I'm running this command prompt back here. I'm actually running in Docker land over here. So if I say Docker, well, let's actually exit. Okay, so I'm back at the DOS command prompt now. So dir, CLS. I'm using DOS commands now. So for some of you, you're like, oh God, I got to do DOS commands. Oh, only to get started, right? So I'm going to do my boot to Docker status. You can see boot to Docker status says it's running. All right, so I did the boot to Docker init and boot to Docker up. All right, and that's what's happened here. So if we go to boot to Docker init, all right. And by the way, there's also, I made a note here. There's also a menu option. So boot to Docker start. I'm running Windows 8. I'm really terrifying, aren't I? I did this on purpose. I mostly run Windows 7 when I run Windows, but Mac is my daily use machine. But I decided to run Windows 8 just to see how it all runs. So there's the boot to Docker start command, which actually does the init and up and IP for you. So you just keep that in mind. Let's get back here. All right, so that's in the menu if you go look at it there. And this is actually under program files, boot to Docker for Windows. There's also a start.sh. So I'm just telling you all these things because sometimes getting it to start is the most painful, hard thing to get it working. Getting it up and running happily is the hardest thing. Once you got it running, you're good to go. But getting it installed, I've actually had to reinstall it like twice on this machine. Didn't work the first time. And I tried installing it offline with no network connectivity. Didn't really want to go. So you got to watch out for that because it's doing some downloads as it gets going. Okay? Once you get it going, you'll want to do things like, you want to do things like boot to Docker init. I won't need to do that. I'll just run it. You can see it says it already exists for me. So boot to Docker init would normally build the VM and get the VM installed under VirtualBox over here, right? So boot to Docker VM is what you'll see in your VirtualBox instance. And then you do boot to Docker up. Mine's already up. Let's see what it says here. Okay, it says fine. But boot to Docker up. And then you want to do a boot to Docker. You can do boot to Docker status, if you can spell status, and boot to Docker IP. So that's an important one for the Windows user. So boot to Docker IP. You can see the IP address it gives me. So that is going to be the IP address of that virtual machine. And so when I launch containers inside it, that's how I'm going to access those things in those containers. So when I have MySQL in there, when I have JBoss running in there, or Tomcat, whatever it is you guys decide running, that's going to be the IP address you want to reference. And then, boot to Docker SSH. Okay? Now on Mac, you don't have to do the boot to Docker SSH. You actually have Docker commands right there at the command prompt for you. And on Linux, you definitely have the Docker commands right there for you. But in the case of Windows, you boot to Docker SSH, which basically throws you into the boot to Docker VM. Okay, so I'm now in the boot to Docker VM right here. So like I do ls pwd ps-ef, right? I'm now living in Linux land. So you got to do the boot to Docker SSH on Windows to get you over here. And then you're now living at the Linux command prompt, basically the virtual machine itself that you see running here in this guy in VirtualBox. That's where you're living. So just keep that in mind. So that can get a little confusing. And I often will have two windows open. So you can see I have a regular DOS window open here too, because I'll go back to DOS land and do some other things. Maybe my Maven compiles over here as an example. Or I might do my file editing over here, because instead of using VI over here, all right, I'll use, on Mac I'll use TextMake, or I use a lot of Atom these days. So like the Atom editor as an example. Or, you might use Ultra Edit, right? Notepad++. But over here you got VI. So just keep that in mind. And for some of you are like, I don't like VI. I know. I barely use VI enough to be successful with it. So once you're in here, you can do Docker. You can just run the Docker command and you'll see, okay, all the different Docker options you have there. So let's look back at our tutorial here. Okay, so the boot to Docker version, boot to Docker init. How many people got the boot to Docker init and boot to Docker up to work so far? Oh, wow, a lot of you. Fantastic. Remember, cheek-to-cheek programming. See someone who raised their hand and go look over the shoulder. Check it out. There's another reason why pair programming works. It's the stress of having someone watch you. The person on the keyboard just works a little bit more aggressively to get things done and working correctly. So yeah, feel free to lean over and go, oh. If they're playing on Facebook, scold them. They're watching YouTube videos, tell them to stop that. We're killing the network here. One tip I'll tell you for Windows users, every now and then when I've done the installation, the SSH piece would fail. I get a lot of SSH errors, and that's because it didn't show up in the path. So I had to manually edit the path. In this case, go add that specific item to the path, and specifically it's the git bin directory. So when it does the installation, right, it does boot to Docker, it does VirtualBox, and does git, and the SSH command's in that git directory. Okay, you run your boot to Docker up, and normally you can see the boot to Docker VM running in VirtualBox. And so for those of you guys with Macs, do you see boot to Docker say running? And on this version of the 1.5 version that I installed on this box, it says off when it's running. Yeah, so you're going to find little gotchas like that, and that's just the nature of the beast right now. It's an open source project that's moving incredibly fast. You might see errors related to VT-X. VT-X, you can see like here's an example of what the error stream would look like. And that's on Windows. You normally don't have the BIOS set up for virtualization out of the box. So if you've never installed a VMware or a VirtualBox on that machine and gone through that issue, you may have to go in there and fix that in your BIOS. Okay, so I actually took a screenshot of me updating the BIOS on this computer when I first received it. And so you will have to make that change. And some of you are thinking, what's a BIOS? I know. Normally when your machine's booting up real fast, somewhere it says hit F1 or F10 to make settings changes. That's what we're talking about here. And you only see it for like 2 seconds, then it goes away. Yeah, you got to be really fast on the keyboard. I can't remember what this machine was, F1 or whatever. Okay? In the case of Mac, right, in the Mac land, you're going to see a message that looks kind of like this. After you do the boot to Docker up, okay, you're going to see it's going to give you these exports. Copy and paste those, export, okay, go ahead and do those exports, and then you can run your Docker commands. If you don't, you'll get a really odd error message. And I took the advantage of screen capturing what the error message might look like. So you're going to get this get sock thing, but this is not the error you were having. Is this the same one? No. Okay. Similar, though.
I think mine is my VirtualBox is out of date.
Okay. But if you don't get those exports just right, you will get that error message. And you can see when I took the screenshot, on December the 3rd. Because I ran into that too on my Mac. Okay? So we did the boot Docker IP, we did the boot to Docker SSH for Windows, and now we're into Docker land. So I can come over here to, I can say Docker version, Docker status. All right? I can do a Docker pull CentOS, and you can see basically it says that I'm already up to date, and that's good because otherwise it would take a long time to get one down at this point based on a network performance. You also have something called Docker images. Okay, keep in mind there's images and containers, and sometimes I use those terms interchangeably, and that's bad. An image is, think of it as the persisted thing, right? And you can actually export it as a tar file and import it as a tar file. It is the static thing. The container is the live running instance of that. So when you say Docker images, it'll show you, Docker images, it'll show you the current images you have on your local machine. This mouse, by the way, if you ever buy a ThinkPad in 2014, you'll want to kill yourself. Yeah, Lenovo ThinkPad 2014 edition has the worst built-in mouse pad, touchpad I've ever seen in my lifetime. And so I've gone back to using an external mouse. I've not used one of these in over a decade because this one built in is so horrible. So that's why you see it doing weird things every now and then, because it's clicking on its own when it's not supposed to. But Docker images, all right, so how many people can see Docker images running? All right, fewer hands, but okay, we got a few of you going, fantastic. So this shows you your local images. You probably have none right off the bat. And if you have those flash drives going around, there's actually tar files on there. You can do a Docker load left paren, right? Less than. And you can import the tar file directly in to get your Docker image. Or you can do a Docker pull to get the Docker image. So either it's going to download it from the cloud, or you can pull it off this flash drive if you want. Okay? So those are my local Docker images. And you notice right here, I talk about the Docker PS command. So you can say Docker PS. That tells you if you have any live running containers. I have none running right now. So I have images but no containers. You can also do a Docker PSA. These are for any containers that were run but are no longer running. And so that's important to note because this will mess you up. So for -A basically says, show me the containers that did run already, because and the reason this is important is when you want to delete an image, you can't delete the image until all containers, including ones that previously ran, have been deleted. So you'll get burned on this when you're like, why won't the image delete? Oh yeah, I forgot. I ran one 30 minutes ago and it's still sitting out there under Docker PS-A. So you can see there's the CentOS one I ran earlier. And so if I do a Docker run -it CentOS bin/bash, this will throw me into the shell for CentOS. And not much change there, but I'm now running in the CentOS LAN. So if I do cat etc system release, you can see it says I'm in CentOS. Okay, if I do a PSEF, there's hardly anything running when I do the PS, right? Because I'm living now inside that container. I'm into the CentOS container, and if I exit out, I'm back into the virtual machine which Docker host is running. So I'm back on the Docker host now, no longer in the Docker container. So let me do a PSEF here. See, I have lots of things running on the Docker host, right? But if I go back to my CentOS, right, PS-EF, I have very little running. So just keep that in mind, right? So this kind of will blow your mind a little bit, right? It's like, okay, which one am I actually in? But if you do a lot of SSH, right, from your Mac to a Linux machine, or from Linux to Linux to Linux, you kind of get used to this concept of I got shell and I'm shell to shell to shell. And so it's kind of the same way here. So now I'm running in CentOS LAN. So now I can do a yum install of whatever I want to install. Anything that's available in the yum repositories. If this was an Ubuntu image, I could do an apt-get. And I got whatever I want to install. I want to install Apache, Nginx, Tomcat, JBosses, Ruby, Sinatra. You go to town. I want the gem. I want Node.js and NPM. You install things now. And the cool thing is you can persist that image based on your new installation. But that's not the recommended way to go about it. So even in the book, it'll say, okay, you basically can run the CentOS and then shell into it, then do your yum, 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 or install your Ubuntu and do your apt-get, apt-get, apt-get. So you can install things manually like you see me doing here, but that's not the recommended way. The recommended way is you do a Docker file, which we'll show you in a second. Right? The Docker file basically says, here's the build description for getting all the things installed that you want installed, and that becomes that immutable image. So let me exit back out here. Let me do a docker ps-a. You can see now with the -a, I've got 3 different CentOSes that have been run. And so just bear that in mind. You notice there's a container ID over here on the far left, and over here on the right, you will see some funky names for it. All right, see it says Thirsty Einstein, Modest Hodgkin, Reverent Lumineer. That's the name it gives it by default. So you can always refer to those things. So if I want to do a docker rm, I can click on this container ID here. And I'll hit enter, and then I'll right click to paste it in. So I can do a remove, rm to remove, docker ps-a. You can see that one's gone now. Or I can refer to it by its name over here. So I can refer to it by this name. Okay, so boom. So docker rm and paste. And so docker ps-a. So I can remove them. I can refer to the containers using the container ID or that funky name it gave me. Or I can give it a name when I run it. Docker run -it -name equal stuff. You got to spell stuff correctly. And CentOS bin/bash. Okay, so now it has a name. If I exit out, docker ps-a, and if I scroll over to the far right, you can see stuff right there. So you can give the container your own individual name. This becomes important when you start linking containers together. You don't want the random names. You want to know that that's my MySQL database, that's my Ruby application, that's my accounting system, whatever it might be. So the naming becomes important as you go along here. Okay? So let's keep scrolling down through the tutorial here. Now, one nice thing about Boot to Docker that is in a relatively recent Boot to Docker edition is it automatically shares with you the local C users directory. So I'm here in the Docker host now, and I'm going to cd into cd users, cd Burr, okay, and then I'm going to do an ls here. Let me go to Docker projects, ls. Let me do ls-a. So if you notice, there's the My App, MySQL app. Those are just little projects. 2 of the projects you guys will create by following the tutorial. But if I go over here to, where did my little directory go? Here we go. Docker projects. You can see there's the same 3 directories here in File Explorer land as we saw here. All right, so let's see if I can pull these both up at the same time. Right here. Okay, you can see those things match. So this is in DOS Windows land, and this is over here in the Docker host in Linux land. So you have the ability to kind of share files between the 2 environments. That's very important because you're going to want to create a Docker file in the My App. You can see the Docker file here, and you're going to edit it in using Notepad++, using Atom, using whatever you want over here in Windows land, but it's going to be visible to you, over here. Right here. So you can see there's the Docker file. You can do a cat Docker file, and there's the contents. If I right click on this and say open with Atom, here's Atom, not that one. There it is. So there's that Docker file, and I can edit the text here, make a save, and then it's still the same file over here. Right? So that's important. And at least from a developer usability standpoint, I think it's very important. So just keep in mind that the C users directory is shared from the Docker host VM out back to Windows land. And so we talk about that here in the demo. You can do things like make dir, right? You can do CDs to change dirs. You can do PWD and over here. You can do, so back over here, you can do PWD to see where you're at. All right, but you're running Linux commands here, right? And regular DOS commands outside of that. Did you have a question?
Yeah, so what on Mac, is that directory exposed?
Yes, actually on Mac, you also have the users directory, so /users. So instead of C, you don't have a C drive, right? But just /users.
User, and then Docker projects?
Make Docker projects to put your files, right. Yeah, you'll have to create that folder, though. I suspect you don't have one yet. Yeah. Okay. So you also saw me do a Docker, let me make this a little bit bigger. You saw me do a Docker run -i -t or -it. That's for interactive terminal session, and I want to have the keyboard capability, so TTY capability, and so I did a bin bash. So if you notice, this was the image name, and this is the command I said to start with. All right, so that's the key thing. So the image name could have been Jenkins, could have been Tomcat, could have been whatever it was, and then I give it the command that I want to run, and that's because I want to shell into it in this case and have a shell to interact with. So that's what I was doing there. And then once you're in there, you can see that we did the cat system release. You can see it's running CentOS in that case. We showed you how to do Docker ps-a. We showed you the Docker images. The Docker pull, as you saw me do earlier, in my case, I have them downloaded. So Docker pull CentOS/wildfly. Okay. In my case, it's going to say, hey, you should already have an up-to-date version, as long as no one's changed it since I started this presentation. And even though it's slow on the network right now, I don't have to go through the process of downloading it. If you do download it, which many of you will, you're going to see a relatively long process of doing the download. But again, you can load the tar file from these flash drives if you want to load it right now. So you can load it right now if you choose to. So actually, I won't wait for that. Let's do a Docker images. And let me do something like, okay, I'm going to do a Docker RMI Ubuntu. I'm going to see, well, let's do something a little cleaner. Let's just delete Jenkins because it's a nice clean one. I'm going to do Docker RMI Jenkins. So I deleted Jenkins now from my local image repository. Docker images. So Jenkins is gone, but I have on this machine, God, this mouse is driving me insane. Docker demo, cd docker demo. I have the Docker images that it's on that flash drive. I'm going to just switch over to that directory. So you can see I have the Jenkins tar right there. I'm going to do a Docker load Jenkins tar. And that'll give me back the Docker image. So that's cool because you can pass it around, right? So you do a Docker save to export it to a tar file and Docker load to import it from a tar file. Oh wow, it's still kind of slow even here doing the load off this machine. It might be. All right, we're not going to wait on it. I noticed I'm not getting the responsiveness. See, it's not responding correctly. Images. It's not responding to anything. There we go. All right, did the Jenkins one finish? No, it didn't quite finish. I think that's the none down there. Docker load and Jenkins. One thing that should be noted too, as I'm running these different Docker commands, the Docker shell actually is just a shell that's interacting with RESTful endpoints running on the Docker host. So you need to keep that in mind. But that's cool because if you know the RESTful endpoints, you can write any kind of script that you want to do anything you want, right? So all this is set up as REST endpoints on the Docker host. I forget the default IP port number that it's running on, so I don't remember that exactly. But you can just use the REST APIs directly with Docker. You don't have to use these shell commands if you don't want to. And that one's not finishing for me here. Let's see, Docker images. Let's see if that finished that time. Okay, it did that time. So there's Jenkins, again, running on my local system. Okay, so what else we have here? So Docker run IT CentOS wildfly. So Docker run -IT CentOS wildfly. Okay, you can see in this case it's booting up JBoss, the application server, inside a CentOS container. And because I did the -IT, I can see the console output. And the cool thing is it pauses at this point at the console, just like it would if I was running it any other way. Yes, sir?
CentOS/wildfly, is that the name includes a slash, or is that some convention you are saying that?
That is the name of the image. That is the name, CentOS/wildfly is the name of this specific image. Yep, and you can see it's now running and sitting here. And now here's the thing that's kind of odd about it. By default, an image that is run, or a container that is run in Docker is not exposed to the outside world by default. So this thing is running on a port, but I can't see it, can't get to it right now too easily. So let me Control-C. One of the things I'll do is let me just map the ports. All right, so I'm going to do a -P. And then, so I'm going to basically say exposure 8080 as my 8080. All right, so -P 8080 is basically mapping 8080 inside the container to 8080 outside the container. And that allows the world now to come in here and interact with that specific that specific app server. So that's it running right there. Okay. So remember that IP address I told you about earlier? Boot to Docker IP, that's it. And then 8080, where I did the 8080 mapping over here. And I Control-C to shut that down. I can also bring this up with a -D. That basically says run it detached. So the container is now launching, but in the background. Right? So the container is running. So if I do Docker PS, you can see that's the guy that's running right there. And I can do a Docker logs and look at that container ID. And we'll paste that here. So Docker logs, container ID. And then I can, and so that's the log file for it. I can do a Docker port and a container ID. And you can see there's the exposed 8080. Okay? So you can have the containers detached and running in the background. You can have multiple of them running in the background. That's not a problem at all. It's just like a Linux process. Instead of using the ampersand for background, right? In this case, I'm doing -D detached. And then I can do a stop on that Docker container. So Docker stop and a container ID and shut it down.
Can we expose multiple ports using this approach?
Yes, you can do -P, port mapping, -P, port mapping. There's an example of that in here also. Okay? Yeah, because you definitely often will have more than one port. Okay?
So if you shut it down, that's a hard shutdown.
The Docker stop in this case, I mean, it's a normal shutdown from a JBoss standpoint in this case, so I don't remember if it's a SIG hup or whatever exactly.
Not doing a hibernate. It won't keep state.
It won't keep state. Yeah, in this case, it's truly shutting down the VM, the Java virtual machine in this case.
Right. But I mean, the Linux image in it, is it doing a shutdown on it also? I mean, that's what it's...
On the Linux container, Docker stop is shutting down the Linux container. Yeah. Yes.
So how do you set up so that processes in two different containers communicate with each other, like a cluster?
Yes, exactly. So that is coming up. That's coming up. So we saw that with the -P 8080. I talked about remembering the IP address. Use Control-C to terminate it. And again, if you have it with -IT, you can use Control-C to shut it down. You can also do this Docker history command, which is kind of cool. Again, you can kind of see the lineage of this guy, so CentOS/Wildfly, and it'll show you kind of who did what and what they did to it, right, basically. That might give you some more insight into how it was created. And then, like I said, the best ones have a GitHub repo which gives you the Docker file and how it was created. So keep that, that's the ones I like at least. Okay, we have you build the My App directory. So I'll show you what My App directory looks like. So I'm going to switch out of here to Docker projects. How much more time do we have? Does anyone know? Oh, we got good time. All right, fantastic. Wait a second. Docker projects, My App. There we go. Not dir, ls. Okay, so there's my Docker file. So in this directory, there's just two files. All right, let me kind of flip over to File Explorer land and show it to you. There's two files. There's the Docker file and the WAR file I have created. So we kind of give you the WAR file out of the box. And the Docker file just contains the commands to do the build of the image. So your Docker files have a from and one from. So from your source image. So typically in a real enterprise environment, you're going to have a series of these things, like build my base OS image that everybody uses. Build my base OS with JVM. Build my base thing with the app server container and the JVM on top of the OS. So you will stack these things. In this case, I'm saying just start with the Wildfly one because I'm just trying to make it easy. So from CentOS Wildfly, and I'm going to do a copy of the local WAR file in this directory over into, right, so that's the WAR file from there, into this directory in the image itself. Because that's where Wildfly needs it to do a hot deployment at startup. All right, so this is the super easiest way to do it. Drop the WAR file in the right location. If I was using Tomcat, it'd be the right location for Tomcat, this kind of thing. And then on Mac, this is not required for Windows, but this is one of those things where it's not quite the same depending on what world you're coming from. On a Mac, you actually need to change the user to root and do a ch-on that file, change owner of that file. Otherwise, it doesn't work right on a Mac. So if you're on a Mac, you need these two additional lines. If you're on Windows, you can ignore them. Doesn't hurt you on a Windows, though. So let me see. I'm going to do let me go back up here. Let me make sure I read the notes correctly. So that's what the file looks like. Okay, you can see the My App. And then you can see what it looks like. And I give you the tip about user root. and then you issue the build command. I'm just going to copy this. The build command is very straightforward. So it's going to be a docker build, docker build, and paste. Oh, it didn't paste. All right, so type it. Docker build -- tag equal my app, and then I'm going to use the directory I'm sitting in right now, so I put the dot. So I do a docker build, okay, and docker images now. So you see there's a docker my app there now, docker images my app. Let's do this, do docker rmi my app. Let's, one more time. We delete it, so rmi is delete the image, and we rebuild it. So it went through its build cycle. So it happens pretty fast depending on the number of commands you've given it, all right? And you can see that when I do docker images, there's the my app right there. So now that means my application on top of the JVM, on top of the operating system with the wildfly configured the way I want it, it's all packaged, ready to ship. So I can now export this as a tar file and hand it off to you if I wanted to. And now I can just run it. So if I come back over here, let's go back, okay? You can see we just run it like we did the other one. Instead of this case, when we did it the 8080, this actually has an application installed in it. So I'm going to say docker run -it -p 8080:8080 my app. So instead of the CentOS /wildfly, I'm just saying my app, which is what I named it. And there it's coming up and running. It takes a little bit longer to boot this one because there's an application inside it. And let's see if it came up good enough for me. And here's the URL for it. So that's it. And it has a built-in database. So I'm going to just give it, some basic information. I'm going to give it a real phone number, or close to a real phone number. And there we go. So that's the application running now. That's the app that I gave you on the WAR file. Okay? So it's that hard, right? So now we need to talk about linking, how to do multiple of these things. But for a single container, as a Java developer, as long as I have my WAR file created already, you just create a Docker file, say what your base OS is, whatever app server combination you want, and then you're ready to rock, right? It's very straightforward. Yes, sir?
Port mappings in the Docker file, or do you have to specify them?
You specify so the question is about the port mappings. You do those at runtime. You do those at runtime. You don't put them in the Docker file. Okay? But you might be thinking about the port mappings for like in link containers, right? So we'll get to linking in a second. Yes?
So the images can get pretty big, right? Because you're putting application server.
Yes, so good question. Images can get kind of big. So let me kind of come over here to the images I gave you on the flash drive. Docker demo, I guess that was there already. Docker images. You can see that that's a 600 meg file. All right, so the CentOS Wildfly was a 600 meg. Jenkins was a little over 600. So yeah, they can get sizable over time, right? It is enough of the operating system, the JVM, the app server, the WAR file, whatever else you've stuck in there. Yes, sir.
Mount OS's disk or another mount, FS mount or sandbox.
Yeah, so the question is about mounting, so you can do volumes specifically, and you can mount volumes across from the container to the host, right? And so the different containers can share like a host volume. In this case, by default, with boot to Docker, I'm sharing the Windows OS C:users.
What about other hosts on the network? Other
hosts on the network? I imagine there should be a way. I've not tried it, but there should be a way to do that. That's pretty standard Linux kind of thing. It is just Linux, right, under the cover. So if you can do that with Linux, you can do it with the container.
The host OS itself is blocking.
Well, in this case, I'm using the boot to Docker host OS, right, the boot to Docker VM specifically. And there are limits with that it's a tiny little virtual machine. It has hardly anything going in it. But if you normally would use like a Red Hat Enterprise Linux, right, or a CentOS or a Ubuntu, you'd use a real Linux to do what I'm doing now. In that case, it's as limited as you are with Linux.
So you could install something like
Yeah. So the question about Oracle, as long as you can install Oracle on Linux, right? Now you do have to keep in mind that your various vendors that sell various products will have to decide if they want to run within containers or not. Because it took them a while to run within virtual machines, right? They didn't all come out immediately and go, oh yeah, we support virtual machines instead of physical hardware. It took a while before they adopted virtual machines as a supported platform. And I expect the same of containers. They'll be a little while for SAP and Oracle and all your big vendors to say, yeah, we run okay in containers too. But it is all just Linux.
So like, for example, like the development environment, you have each developer have their own database instance, which you package something like an express version, Docker image.
So the question was around Oracle Express and then having that available to all developers. And so in that case, I would probably have a Docker image specifically for standing up that Oracle instance, and then they would all each run their instance for their specific needs, right? But that assumes Oracle supports the container format. Then I'm sure it runs, you know, but they may have some rules associated with that. Oracle can be very fickle.
But the thing is, on one side you're saying it's database, right? On the other side you're saying Oracle has to be kind enough to say, hey, we run inside a JBoss. So which one is true? Which one is Linux?
Yeah, but
Oracle should be transparent,
right. But a vendor is a vendor, right? A vendor has rules, and they may choose to, you know, to say, no, we don't support that. For instance, Oracle doesn't run on Mint, right? They just don't support Mint. It's just Linux, but they don't support Mint. They choose what they want to support. I'm sure Oracle will just run in most cases, though. Okay, let's bring this server down here. There we go. All right, so we got that guy running Docker PS. Let's see what's running out here. Okay, nothing's running actively right now. I have a bunch of extra credit tips and tricks at the bottom of this document. So a couple of things that are good to know. You can do container naming, -- name. I showed you that earlier. You can do a Docker logs. You can do a and this is actually particularly powerful. Remember this one, because you will get burned on this one. At some point, the container is going to start, and if you did a -it, you're going to see an error message go by, and boom, nothing happens. Or better yet, you see nothing happen. The container crashes upon arrival. So when that happens, there's one key trick to remember is you can actually override the command in which it runs, and you can see here in this case, if it's already running. Like if it's already running, I can do an exec of that container name and bash into it. So I can shell into the running container and then poke around. Or I can just put /bin/bash at the end of it and shell into it immediately and then start seeing what's in the log files, why is it crashing immediately. Because I definitely have had that problem myself. It's like it's not running correctly, let me shell into the live running one, or it crashes upon start, let me run bin bash and see what it looks like. You know, it's giving me some output. And then you can actually test the commands individually. Like I said, start the JVM. Well, you said to start the JVM with the wrong path. No wonder it's not running. You know, and that will happen to you. I said start the app server, you know, whatever it would be, Tomcat, JBoss, etc., and it's not running because again you probably used the wrong command. So this bash trick allows you to get into it, run the commands manually. Oh, now I typed it wrong. Fix your Docker file, rebuild your image, or fix your command line. Another one I like to use, and I'll show you this one in action, is you will eventually have tons of these things running, right? And you might want to just say, you know what, I need to clean it all up. As a developer, I want to clean it all up, and I can do Docker RM, the single tick, Docker PS-A. So Docker PS-A-Q just gives me the image IDs, and I'm basically pumping that into Docker RM and saying wipe them all out. So at this point, I just killed all the Docker processes, all the Docker containers that are running. And if I want to, I can do the same for all the images I have locally. I'm not going to do that because it takes too long to download on this network. But you can wipe out everything and kind of get back to a clean slate. And I've done that multiple times just to make sure that my instructions were correct too. Let me back all the way back out and see if I can get it working again. Okay? So let's talk about linking. How much time do we have left? I don't know what our end time is. 14 minutes. Okay, we've got time to cover linking. So this gets a little bit more interesting. We showed you a simple app server, get a WAR file in it. Let's kind of show you what it takes to link two things together, and the links are where the magic is, and I'll show you a trick related to magic. So you can do a Docker pull MySQL. All right, so if you guys are following along, feel free to do Docker pull MySQL. I believe I put the MySQL tar file on that as well. Did I? Yeah. So you can just do a Docker load, right, less than MySQL tar to get the Docker image loaded there. Okay, and now to start the MySQL image as a container, it actually is a fairly long command line. I'm going to copy it out and run it, and I'll explain what all these things do. So let's do a paste. Okay, So it's got Docker run. You guys are used to that. -- name. Hopefully that's pretty comfortable. And you notice I gave it MySQL DB. -p 3606 or 3306, 3306. All right. So -p. You guys good with -p? That was the port numbers. All right. Port numbers. So MySQL by default runs on 3306, and I just mapped it through from the container to the host. -e is a new one to you, right? That's the environment. And so I have the environment, and I have a MySQL user, MySQL password, MySQL database. All right, so those are my environment variables I'm establishing within the container. All right, I'm basically saying, hey, container, when you run, here's some environment settings that I want you to have. And then I also have the MySQL root password super secret. -d is run detached in the background, and then the name of the container. There's a lot going on there, right? So the name of the container is MySQL, but all this other stuff are parameters and to make that MySQL run a certain way. And you can see it gives me the, I can do a Docker PS, right? And that's the container ID. So MySQL is now running in the background in this Docker container. And remember, I have an IP address set up. So I should be able to connect. Let's see, if I connect here using MySQL Workbench. And if I connected correctly, now the funny thing is I'm trying to query for a table and database that don't yet exist, so that's why it's giving an error message. But I did connect to that database. So from Windows, I've connected to that Docker container MySQL. Okay? So now let's show you the next half of the equation for the linking piece, because this is the gentleman back here who really wanted to know the linking. Okay? Let's go down here. So set up MySQL. So all the instructions for how to set up MySQL so you can connect to it. Though I have an older version of MySQL in the box I took screenshots from. And in this case, we're going to have you do another Docker build and another war file. So I've already done that. So MySQL app right here. But I'll show you, let's just build real quick. Docker cd MySQL app. Okay, so Docker build there. I've already built the war file. I'm not going to build that again. But I guess I'll walk you through a couple things. So these are the things that you have to think through when you're linking two things together. Okay? So in a Java EE application, you have this persistence XML. So if you've done enough Java EE, persistence XML hopefully is not a problem. And you have the concept of identifying your GIND for your data source, right? The Java naming directory interface. That's the GIND name of my data source within the app server. So Tomcat or JBoss or WebLogic or WebSphere, right? They have the same concept. I have a data source. And so outside of that, right, outside the application itself, in the case of JBoss, we have an XML file for mapping those data sources to the actual concrete JDBC connection that it needs to make. So am I connecting to Oracle? Am I connecting to JBoss? Am I connecting to Oracle? Okay. Or am I connecting to MySQL? Or am I connecting to Postgres? And so you can see here, I'm connecting to, we're using the JDBC connection string of my database server there. Do you guys see that? And 3306. And sample. So that's important. So there needs to be a host out there someplace called my database server with that port number on it with that sample database. That's how you connect to MySQL. And if it was Postgres, it would look like something similar. They all work about the same. So I'm expecting my database server to be a server living and running on the network someplace. All right? And this little data source configuration file is what boots up within, in this case, JBoss to say, yes, this data source has to connect. And you can see it also gives this jar file. Right, the driver itself. And in this case, I have you drop all that into the directory. So you can see right here, here's the application that I have you build, right? That's a standard Java EE application. There's the Docker file, which we'll see in a second. So there's your JDBC driver jar, the DS file I talked about. And there's also a change made to the standalone XML. And if we look at the Docker file, okay, if we look at the Docker file, it copies the standalone XML into the container. It copies the jar file for the JDBC driver into the container. It does the DS file for the data source configuration into the container. And then it takes my war file, right, from the target directory, pushes it over the container. And then it does last thing it does a run to give it a user on that app server. All right, so in this case, there's now an admin, and that's the password for it, admin bang 1234 as the user on that app server. So you notice your Docker files can be fairly complex. You can copy, run commands, you can execute anything you want to execute. apt-get, yum installs, whatever you need. You just put them all down there and it does what it's supposed to do. Yes, sir?
Does it always run as root by default?
It always runs as root by default. Right, and you can also put in, if you want to run by something else, you can say user and the other user ID and group ID you want.
And you can switch back to root if you wanted to.
Yes, and you can switch back to root, and after that command, you can switch back to root over here. So you will see that in some of the more complicated ones. You'll see switching users, because I have to have it set a certain way. I might add a group or add a user using the appropriate Linux command. So the Docker file contains all that, which is nice. Okay, so I notice there's a lot of moving parts here, so just remember, this, inside the war file itself, it refers to this GIND, MySQL sample DS, right? And that gets mapped to, click, that gets mapped to my database server running on 3306, okay? And if you remember back to our MySQL, so MySQL, Docker port, and let's see, it's MySQL DB. Okay, you can see MySQL DB running here already is running on 3306. All right, so the MySQL is out there running. So let me do the build on the Docker host. Oh, we're working on that. Yeah. So what you'll see it right here. Okay, so there's the Docker file, and so let me do. Here's the Docker build command. Very simple. And I'm in the right directory. Wrong one. I want this one. I don't like this mouse. Go away. Just get rid of that one. All right. Look at that. I don't want to run the database again. Okay, we're just going to type this thing in. All right, so Docker build. Tag. And I want to call this MySQL app. And I think I already have one of those out there, so I'll just call it MySQL app 2, just to be on the safe side. Okay. All right, there we go. So it's doing a build. Fantastic. Docker images. And you can see MySQL app 2 right there, right? Okay, now, so here's the magic. Notice right here, when you do your Docker run of it now, you do this thing called a link. Okay, let me kind of zoom in there so you can see it. The link is the magic. So what this does is it basically says from the Docker host, I have this thing called MySQL DB. Map that into the containers, my database server. So the container is looking for my database server, and the MySQL DB coming from the host is getting mapped in. And the way you test this, so let me go ahead and run it. And the way you can test it and see it better, Docker run, Docker run dash, let's do dash IT dash P. We'll do the 8080. Okay, and then make sure I do this right. Dash link, MySQL DB, because that's the container that's already running, and then my database server is the one I want running, and a MySQL app 2 is the tagged image that I just created. But I'm going to do one other thing here. I'm going to do an env. So this is a good tip for you to remember. So env basically says run the container, but just dump out its environment. That's really cool, right? Because now I can see, okay, that container didn't really run. It just ran the container fast enough to run its environment. And you can see the my database server right here, all listed. If I come back to this command and I make it a funnier name, let's call it MySQL database server Burr, and run it, you can see now the environment variable changes. So inside that container, it's looking for this environment variable that it maps to the data source, right? That maps to the GIND, which the application is looking for. So that's how all the magic works. So linking up multiple containers is simply through this linking mechanism, and it's just sharing environment variables, right? So it takes a little while to get your head around it. It did for me, at least. I had to play with it like for 8 hours one day until I got it. And it's really that the env trick that really, when it spills out the environment, that you get a chance to see it. So if I come back here now, delete that so I have the right environment variable name. Database server. Database server? Yep. Oh, I didn't quite get it right, did I? Yeah. Let's see there. All right, good catch. And we'll run it. And as it's coming up, let me do not up yet. Come on up. Not yet. Almost. There we go. So let me put my name in here. Red Hat. I can't hardly see here, so register. Get the right phone number. There we go. And if I come back to MySQL, And again, the super secret. Oh, come on, mouse. Work with me. And let's run that. There you go. So it's actually in the MySQL database. So that's connecting it all the way through. So that kind of shows you a lot. And I know I kind of ran through a lot of this rather quickly, but we didn't have a lot of time together. Did anyone else get the MySQL piece connected at all? Nobody got that far? But how many people got the app server up with the WAR file running in it at least? All right, a few of you. Fantastic. All these stuff is up here on GitHub. All you got to do is go review it. You can hit me up on Twitter or hit me up on email. I'm Burr at Red Hat if you have more questions. But please go through these exercises. And if you have any troubles, let me know. I want to see it work for you. And that is that. Thank you all very much.